Good day, my dear students, and welcome back here again in our chemistry class. And for today's videos, I'll be discussing types of chemical bonding. So for the chemical bond, definitely it's an electrical attraction between the nuclei and valence electrons of an atom. So this attraction is also called as intermolecular forces, which it has three types of chemical bond that might exist: ionic, covalent, and metallic bond. Now, so you can see here, when you say ionic, is a summary. It results from transfer of one or more valence electrons, metal and non-metal elements. Covalent bond result from sharing between non-metals, and metallic bond is holding metal atoms, which they are called metallic bond, and highly mobile valence electrons in the atoms. Now, when we say ionic bond, definitely they are formed between a metal and non-metal due to a large difference in their electronegativities. And their electronegativity is a measure of the tendency of an atom to attract electron in a bond toward itself, such as cation, anion, and a formal unit. Now, if you will go back in my previous video, I already discussed the parts of the periodic table, and there it was being categorized where is the metals, non-metals, and the metalloids. Now, here in the ionic bonding, one of the examples here, the most famous one, is the sodium chloride. The Na, or the sodium, it is considered as metal, and the chloride or the chlorine considered as non-metal. That is why when you combine them, this become, or this was been called as ionic bonding, because they're a combination of metal to non-metal, where the metal transfer its electron to chlorine to complete its valence electrons. For covalent bonding, two atoms of nonmetals, similar or different elements, share electrons to obtain stable field octet. So this type of bond holds them atoms together in a definite arrangement and forming a molecule. The sharing of electrons pairs to form independent molecules may occur equally or unequal. Now, when you say valence electrons, definitely is a representation how does a certain atoms or an element able to fill an 8 valence electrons, which is called as the octet rule. So when you say octet rule, it follows the 8 rule. So when you count the valence electrons, that is 2, 4, 6, and 8. If you're going to check the valence electrons here on the atom B, it has 6, right? And 2, 4, 6. Since they will be added, and for the atom B able to complete the octet rule or follow the octet rule, the atom A must share its valence electrons to atom B for them to be counted as a whole. So if you're going to count, that will be 2, 4, 6, and 8. And then on the atom B will be 2, 4, 6, and then 8. So there in the covalent bonding, definitely it's a combination of two nonmetals. It should be 2 or more non-metals. Now, here's the electronegativity that I'm talking about a while ago. When you say electronegativity, it's the ability of an atom to attract electrons in chemical bond. It's a measure of how strongly an atom attracts shared electrons when forming a chemical bond with another atom. Now, this is a very different chart from the periodic table. So in the periodic table, it represents the atomic mass, the atomic number, and the symbol. Here in the electronegativity, it shows the charges or the electronegativity itself of the different elements here in the periodic table. So here in the hydrogen, we have 2.1. In lithium, we have 1. Beryllium, we got 1.5. Boron, 2. Carbon, 2.5. Nitrogen, 3. So on and so forth up to the end of this periodic table. Under the covalent bonding, with the help of the electronegativity, this will help us to identify if their bonding is nonpolar or polar covalent bonding. But first here in the nonpolar covalent bonding, it says here that The balance distribution of electric charge is equals to electrons spend the same length of time in the locality of each atom. So definitely, if we have two hydrogen, it forms a hydrogen gas molecule. So this will become a non-polar covalent bonding. For polar covalent bonding, it says here that it is an equal sharing. The atoms do not equally share the bonding electrons because they are different atoms with different electronegativities. And this unequal sharing is also called partial electron transfer. So definitely there will be a small electronegativity added to a greater electron negativity. So based on the representation here, you see we have the pink one added to a more electronegative or greater electron density. Now, the two partially charged regions or poles of a molecule are transferred to as a dipole. A dipole is symbolized by an arrowhead. So this is our arrowhead. Then pointing to the more electronegative atom, which is a negative pole, and a cross tail located at the less electronegative atom, which is positive pole. So there, this shows, for example, we have iodine and chlorine, and definitely we have higher electronegativity on chlorine. For you to know and identify the bond classification of a certain element if they are nonpolar covalent bonding, polar covalent bonding, or ionic bonding. So we'll be following these ranges. If it is 0 to 0.5, that is nonpolar. 0.5 to 1.7, that will be polar covalent. And when you say 1.7 or greater, that will be ionic. Since you're that, these differences are subjective and may be cited differently. And these ionic bonds are actually electrostatic interactions and not real bonds. All polar covalent and ionic bonds share electrons to some greater or lesser degree. Now, how can we identify if it is non-polar or polar? So definitely we'll get the electronegativity difference. So we just simply subtract. So here's the example for us to know if it is polar or non-polar or ionic. Now, let us first identify which has more electronegative atom. So we have here sodium and chlorine. So sodium, if you're going to look here at the chemical or the electronegativity chart, sodium has 0.9. Sodium has a 0.9 and then chlorine has 3. Chlorine has more electron negativity. Now, what is the electronegativity difference? So we just simply subtract. So 0.9 minus 3. So that will be 2.1. So since the difference of this electronegativity of sodium and chlorine, that is 2.1, and if we're going to go back here in our chart, so sodium chloride is ranging to 1.7 and greater. So definitely, this sodium chloride is considered as ionic. Now we have iodine and chlorine. So let's check the chart. Iodine has a 2.5. Chlorine has 3. So as we get the electronegativity on the chart, so still the more electronegative atom here is chlorine, which is chlorine has a 3. Now we need to get their difference. So 2.5 from iodine, we subtracted to 3 electronegativity of chlorine. So their differences will be 0.5. So there, we go back again in our chart if we have a 0.5. So definitely iodine chlorine, and chlorine has a greater one. So definitely we consider as polar. Next, H2. Then the more electronegative negative atom. Let's check. Now here in our H2, let's check who has more electron negative atom. So definitely they're both 2.1. So we write here that hydrogen has none greater electronegative atom. None, because they're the same. So their electronegative difference, so 2.1 subtracted to 2.1, so definitely that will be 0. So we go back again in our chart. So this classified as non-polar. Here, in getting the electronegative values of a certain compound, so you just simply check their electronegative based on the chart and then get their differences. So just simply subtract. Now, here are the common names, chemical name and chemical formula of the different compounds. So it varies. We have the aqua oxygenada or the hydrogen peroxide, which has a chemical formula of H2O2. For the alcohol, we have the chemical name of ethyl alcohol, which has a formula of C2H5OH. Ammonia, chemical name still ammonia, and the formula is NH3. For the laughing gas, we have the nitrous oxide, which the formula is N2O. Limestone or the carbon carbonate as a part of the chemical name, its formula is CaCO3. To sum it up, compounds may be classified based on the type of bonding between elements such as ionic compounds or covalent compounds. Now, to make elements easier to describe in written form, chemical symbols are used. Now, compound can be represented by a chemical formula or combination of chemical symbols of elements that constitute the compound. Now, that's a summary of the types of chemical bonding. So, if you have concerns or you need some clarification, you may screenshot one of the frames here in my video and you can directly message me so I could help you. And with that, thank you so much and see you on the next video.